And thank you for being here. I hope you had a little bit of lunch. And this is our first lunchtime lecture on a very interesting subject, full of debate going on. And I'm sure our expert, Stig-Morten Knutsen, for the Norwegian Offshore Directorate and Vice Chair of the Bureau of the Expert Group on Resource Management, will tell us a little bit as the status. Norway, as you know, is one of the countries most advanced, I would say, in looking at this issue. And therefore, we thought it was a good idea to bring in the framework of our discussions around resources as well the issue around seabed. As you know, we don't cover, at EGRM, we do not cover seabed minerals, but we do work on them, and certainly the tools that the EGRM have developed are applicable to that sphere as well. So with that, I would like to give the floor to Stig-Morten, and thank you very much for spending your lunchtime with us, illuminating us about seabed minerals. Thank you.
Thank you, Dario, and thanks for inviting and thanks for the introduction. So I am with the Norwegian Offshore Directorate. That is a governmental body, a governmental research body under the Ministry of Energy in Norway. And we deal with seabed minerals, we deal with CCS, we deal with oil and gas. We also give advices on offshore wind, offshore aquaculture, and I shouldn't say whatever else might happening on the offshore areas, but I'll get back to that in a minute. We have the presentations we do, and I guess I should start with a disclaimer because that was indicated before the break. This could be a controversial theme. I don't know how controversial it's going to be, but I am not giving this on behalf of EGRM. I am giving it on behalf of the Norwegian Offshore Directorate. So just to make that one clear. Okay. I don't know how much you know about seabed minerals. I'm going to talk about seabed mineral activity, and that's what we call it in Norway. And the reason I'm going to call it that, and I'm going to talk about that, is that there is no place on Earth, and it has never been, no place in any oceans where there has been commercial seabed mining happening, and it's still not happening. And I also am aware that there is a lot of, how should I call it, perceptions and pictures and so of what seabed mining or seabed mineral activity might be. And you see some of them on the screen. The one to your left is from the United Nations. The one from the right is what I have seen when I have spent months trying to map and investigate seabed minerals on the Norwegian continental shelf. And I'll get back to that also a little bit later. So this is what I'm going to try to cover. I'm going to try to say a little bit in general about seabed minerals. I'm going to say what they are, where they are, and how they are made. I am a geologist by training, but I'm not going to bore you too much because then you might going to fall asleep. We'll see. Then I'm going to jump into a little bit about the myths and the facts, some on the environment, some on the technology, some on the potential profitability, and a little bit on regulation, especially from the Norwegian side. I'm not going to say too much about the strategic resources. We heard already this morning a little bit about that, but it is something that we in Norway are looking at, and I'm sure that the EU and Europe and the West in general is looking into that as well. And then I'm going to end up with a summary. So that's sort of what I'm going to hope to get through before we move on. On your right-hand side, what you see is Jøtul. And Jøtul is a black smoker that I was so lucky to discover together with a German expedition a few years back. And what you see is also on the uppermost part, you see the probe from the ROV where we are measuring the temperature of this hot fluid coming out of that black smoker. And what really this is the birth of sulfides. And I'm going to talk about sulfides because sulfides is one type of seabed minerals. And just to make that one clear, in Norway, I shouldn't talk for any other countries, but in Norway, these active black smokers or active hydrothermal vents, as we call them, they are protected. So this is not the one we might be investigating further for potential seabed mineral activity, as I want to call it. So what are minerals? I guess many of you know what minerals are, so I won't talk too much about that. A mineral is a naturally occurring inorganic element, compound, all I shouldn't say all of you know that, but that is sort of the definition of a mineral. Gold is a mineral, cobalt is a mineral, lithium is a mineral, etc., etc., etc. Deep sea minerals usually are described under 3 different types of approaches or occurrences. It's the sulfides. I already mentioned that a bit. I'm going to talk a little bit later about how they are created. It's the manganese crust. Thank you. And it's the manganese nodules. Those are the 3 types that we usually talk about. And as it says on the screen, the depth range is from a few hundred meters down to 4,000, 5,000 meters, but the majority is between 2,000 and 3,000 meters. And what you see on the lowermost part on your right there is sulfides on the lowermost left part. And there's no scale on that picture, but that picture is about half a meter. So that blackish thingies, that is sulfides. That is a mound of sulfides on the mid-oceanic ridge on the Norwegian continental shelf. What you see on the far right side is examples of crust, ferromagnetic or polymagnetic crust that has grown bit by bit. And again, I'll get back to how they are formed without being too boring. This is actually a microscope, so you actually see the layers of the growth of the crust, how they grow. Those are the 2 types we have in Norway. We do not have manganese nodules in Norway. But manganese nodules is very much known from other parts of the world, especially from the Pacific, from what is called the Clarion-Clipperton zone and other areas. And I'll get back to that as well. And I realize, as I say, I'll get back to a lot. We'll see how long we're going to keep going here. So where are these seabed minerals occurring? And if you look on a map, you will probably be familiar with that the most of what we call planet Earth is actually planet ocean. The surface of the Earth consists about 70-71% of sea, and 29% is land. Of those 71% of the seas, about 54% is outside national jurisdictions. And that is the blue things that you see on that map. And in those areas, the blue areas that you have on your map, that is where the International Seabed Authority regulates potential seabed mineral activities, the ESA. The ESA is an autonomous body under the United Nations Conventions Law of the Sea, the UNCLOS, and it's currently working in Kingston. It's actually currently working. It is residing in Kingston, and it has a session right now trying to work forward towards deep sea mining rules. They have been working on that for, I think it's 10, 11 years or something like that, and they are trying to progress towards that. Those are the blue areas. And then are, of course, the areas that are within the national jurisdictions. For instance, that red ring that you have on your screen, and that is the Norwegian jurisdiction. So that is the Norwegian continental shelf. So we have to separate on the regulative side from the ESA, from the outside any country's responsibilities, and from the national jurisdictions. Norway is one of them, India is another one, China, etc., etc., etc. And this is a map of the Norwegian continental shelf. I don't know how well it is displayed, but Norway has a lot of activities on our extended continental shelf. And there's a lot of reading, you don't need to go through that. But what you see on those colors on the shelf, because you see Norway and you see Svalbard and you see Greenland, and up to the top is the North Pole. And on that, within that border, which I can't point to, but which is the black line, that is the extended Norwegian continental shelf. And that shaded area that you see on that extended continental shelf is the area that we in the NOD has been investigated for seabed minerals. So it is about 600 kilometers out, and it is about depths of 1,000 down to 2,000, 3,000, 4,000 meters. Did you lose it, or did I lose it, or did everybody lose it? So for Norway, when we do seabed mineral activity and mapping, we do it way out and way off, to put it that way. And I'll get back a little bit more to what is happening. All those colors that you see on the map is either fisheries activities, it's petroleum, it's offshore wind, it's military, it's transport, and whatever have you. But we are, I shouldn't say glad, but again, I would point to the issue that we are far away from any other activities on the Norwegian continental shelf when it gets to seabed minerals. Okay, So how are these seabed minerals made, if you want to put it that way? Let's talk about the polymagnetic or the manganese nodules first. These are potato shape or bullets, whatever you want to call it, 5 centimeters, 10 centimeters. What you see on your right-hand side is about 5 centimeters nodule from the Cook Islands. And the way they form is that they usually grow surrounding a nucleus. And that nucleus could, for instance, as it is, I think in this case, a teeth from a shark. And then it starts rolling, and it starts participating, and it starts growing. And it grows slowly, very slowly. And there's a quote, a few millimeters per million years. We have seen other numbers. But that is the way they are created. And then they are, as you can see on the left part of the picture, they are spread out on the seabed, especially in areas of the Pacific. So that's the polymagnetic or the manganese nodules. Then I'm going to talk about the sulfides. And what you see on your left-hand side is a map of the mid-Atlantic. And if you remove all that water, I guess many of you are familiar with the mid-Atlantic ridge. That is more or less how it looks. This is an old map, as you can see, but it's still nice, I think. And it shows the mid-Atlantic ridge going from south to the north and all the way up until the polar oceans further north and up side of the picture that you see. And the reason I put up the mid-Atlantic ridge is for the sulfides that we are doing and mapping in Norway is it is along this ridge it is formed. And it is formed because the conveyor belt, if you want to put it that way, where the spreading is happening along that ridge, where the continental plates slide apart with a few centimeters a year, that is where the sulfides are born, if you want to put it that way. And the way that is happening is what you see on the left-hand side of this slide. There is a lot of water from the deep oceans flowing down into cracks and fractures in the seabed. And as they flow down, they meet the heat and the fluids from the depth of the earth coming up. And then this is pumped up again along this, as you saw in the beginning, these hydrothermal fields. And while that is happening, they bring along with them a lot of different minerals and metals. And then the sulfides are born, if you want to put it that way. And what you see on those pictures is a lot from what I have been mapping together with the German research institution. And it shows some beautiful features along what we call the Moons Ridge. It's 200 kilometers west of Svalbard, and it's about 3,000 meters depth. And again, as I said in the beginning, these are protected. The only one that we might consider working further with is what you see on the upper left-hand side, which is a sulfide mound. And what you also see on that upper left-hand side is the front of the ROV. So that indicates it's about 1 meter or 2 meters on that pictures. So that's the sulfides. And that was the nodules. Then the crust. And the crust, the polymagnetic crust or the manganese crust forms in a little bit the same way as the nodules. They are actually participating out of the seawater if you do not have a lot of other sediments polluting the system, if you want to put it that way. So that is actually how it grows on seabed mountains or obstacles or whatever have you. And what you see on that right-hand side, and there's even a scale, is part of a crust that we have cut out with a chainsaw. It's not more complicated than that, the way we did it for scientific reasons. And that is about, I think it's about 20 centimeters thick. And we have used a rule of thumb that it grows with about maybe 1 centimeter a year. So if that's 20 centimeters, that took 20 million years to grow. So then we have talked about the creation of the nodules, of the sulfides, and of the manganese or polymagnetic crust. So then we're going to move on to where is these activities happening. And first, I just want to put your attention to the left-hand side, and that is actually something I stole from BBC. But what it shows is the different areas that the ESA, the International Seabed Authority that I talked about in the beginning, where they have awarded exploration licenses. Some for polymagnetic sulfides in the mid-Atlantic. Most of the exploration licenses are in what is called the Clarion-Clipperton zone in the Pacific, where they are mainly looking for polymagnetic nodules. And then there is something in the Northwest Pacific and also something in the Indian Ocean. For many years, it was said, not for many years, for a few years, it was said that Norway would be the first country to put forward a licensing round on offshore seabed minerals activities. That did not happen because just a few, should I say, a few weeks back, India announced what you see on that right-hand side, where they actually announced 3 blocks for lime muds, 3 blocks for construction sand, and on the far lower right-hand side, 7 blocks for polymagnetic nodules on their continental shelf. So that is a licensing round that is already ongoing in India. But it's not only in those areas that you saw on that map. We already have in Sweden, there are exploring for nodules that you see on your the left-hand side. That has been ongoing for a few years. But also from Japan, there is actually exploring for rare earth rich mud from very deep parts, down to 6,500 meters. And where they have an ambition in about 2027 to pump up 350 million tons of this, how should I put it, stuff or slurry, and then extract the rare earth minerals from that one. So there are things happening elsewhere as well. Oh, here we go. And then it is the Clarion-Clipperton Zone, or the Pacific, where there are a lot of different institutions and countries having exploration licenses. China has, Germany has, France has, Poland, Cook Islands, and you can go into the ESA homepage and you can see who are actually having exploration licenses, not only in the Clarion-Clipperton Zone, but in general under the regulations of ESA. So there is a lot of activities going on, not only in Norway. So, a little bit on the myths and facts. How long time did I have? I don't have a... Is it?
Half an hour.
Half an hour, okay. This is a picture that is from the World Wildlife Fund, and they are one of the opponents towards seabed mining. And as I say, our worst fears are our strongest triggers. There is a lot of debate, and I'm fully aware of that, on seabed mining or seabed mineral activity or whatever you want to call it. Some say it's irreversible impacts. Some say there's a lot of future opportunities. The thing I would like all of you to remember is that we don't know, because this has not been done. There has been some tests, and I am aware of the studies on some of those test sites, but there has been a lot of developments since those tests happening, should I say, 5, 10, 15 years ago. And none of the things that you see on that screen is what we, at least in Norway, envision from the way we would like to do it. And I'm not going to talk about ESA or any other country's legislation, but this is not what we think is going to work, to put it that way. Also, we do see this one from Greenpeace, where they say that deep sea mining is the practice of mining metals and minerals from the seabed, and it would damage the oceans beyond repair. That is also, I think, in many ways an interesting saying, because it hasn't been done yet. So how do we know that that is going to happen if we haven't done it yet? And again, I am fully aware of all the discussions and all the controversies about this potential activity. But what I do know is that a lot what we already are doing when it comes to mining on land might not be what we want to do or have a sustainable system. And that is also something I think we should keep in mind. In Norway, when we had these discussions on seabed mining, these are the pictures that very often are used, not very often, they have been used by the opponents. And what you see on the left-hand side is a black smoker. So it is from what we call the Knipovich Ridge. You see these beautiful structures pumping up black sulfide smoke, and they are growing. And as I also said, these are protected. On the right-hand side, you see also a picture that has been used when somebody wants to oppose to seabed mining. And nothing what you see on that picture is getting close to what we see when we do actually go down and do the mapping of these type of resources. The crab that you see on that picture usually lives down to 40 meters. It might go down to 200 meters, but not deeper than that. And that is way, way shallower than those areas that we are looking at seabed mineral activity. So when I have spent my months mapping these types of deposits, this is what I see. And this is what I see. And it's, in many ways, I know it looks boring, and I shouldn't say that there is no life or whatever on here, because it is probably. There are bacteria and there are other ones. But don't get too tricked and don't get fall too quickly in love with those pictures that you sometimes see when seabed mineral activity, or mining, if you want to call it that, are being discussed. This is what I have been investigating, as I said, for months. And what do we actually know about our planet Earth and the creatures living here? This is from a paper, I think it came out in 2011, if I'm not mistaken. There is a link on and I'm going to provide this later on. What was said, or is said, is that there is about 8.7, assumed to be about 8.7, it said, eukaryotic species, and that is actually multi-celled organisms on Earth. And that is, if you look on the left-hand side of your slide, that is split between land, where it says about 6.5 million, and in the oceans, 2.2 million. And then it also is said in the same article, it is said that we don't know about 5.6 million species on land, and we don't know about 2 million species in the seas. And since there are so much more sea than land, what those that have done the math and the statistics say is that there is 7 times more likely to find an unknown species on land than in the seas. And in addition, if you look at that middle bullet point to your right, it actually says that if we as humans are actually to go through all these species at the same pace that we have done so far, it's going to take 300,000 scientists, 1,200 years, and $364 billion to do that job. So we are lagging behind, be it in the oceans or be it on land. And that brings us to that tricky one, and these are some pictures that some of you might be familiar with, but how do we do sustainable resource management? How are we doing it today? And how are we going to do it in the future? And is that thing that you see in the lower middle part, is that part of, or could be part of the solution, if you want to say it that way? That is a sulfide mound, again from the Norwegian Greenland Sea, and within that area that we have investigated for seabed mineral activities. Let's talk a little bit about technology, because there's always been said, oh, we don't know nothing, and it's not, the technology is immature, and it's so and so. And I would say it's not. A lot of the technology that we hope to see, if we are going further with seabed minerals activity in Norway, are already available from the petroleum industry in different varieties. And what you see on just on that left-hand part of that scheme is the objectives, be it on the crust or on the sulfides or on the nodules. And you also see an ROV, you see the AUVs, and if you look on the far right-hand side, when it gets to riser system and pumping, we are already doing that from depths way, way deeper or longer away than the seabed minerals might be. And also, this is from different types of technologies that might be used. And one of the really big concerns when it gets to seabed mining is the sediment plume, that you're going to stir it up. And we think that it is possible to do this kind of activity without having the sediment plume being a critical factor. And what you see on the top left part is actually some robotic systems that are being developed in Norway, where they are actually running along the sea surface and scraping off the crust. The systems for nodules that you see on your lower left-hand side is already present, and also the drilling for sulfides that you see on the right-hand side are being proven. And actually, as I speak now, we in the Offshore Directorate have scientists out together with the university and together with science communities in Norway doing exploration in that way. So it is already ongoing. And just also to prove this one little picky, I shouldn't say, this is a system that was already presented in Time magazine a few years back from someone called the impossible metals. How do we pick literally pick the polymagnetic nodules without disturbing the subsurface too much. And that is also something that is being worked on, and it is being investigated. This picture shows on the left-hand side, on the left-hand side shows a little bit about the energy use in the processing. And what it shows is the energy intensity in gigajoule per ton copper versus the ore grade of copper. And what it shows is when the ore grade increases, the energy demand falls. The point for me to show this is that what we have seen from the samples we have picked up from our areas on the Mid-Atlantic Ridge and in that area that is open for seabed mineral activity is that the ore grade can be as much as 5 to 10 times as high that we usually mine elsewhere. And that will give an impact on the processing of these minerals and metals. On your left-hand side, you just see different types of CO2 equivalent emissions on the offshore compared to the onshore. You see some solid waste, you see some megafauna, wildlife at risk, and there are papers coming out on, how should I say it, on both sides, on the pros and cons, but this is just one of them showing that we do believe that it could be a solution for seabed minerals to actually have a less strong environmental impact than maybe parts of what we are doing on land today. This is probably not easy to see from the room, but what it actually shows is the resource estimate that we have done in Norway, and that report is public. There's a small number for copper, for zinc, for gold, for silver, etc. And what we have done is based on our mapping and resource assessment so far, we are saying that we can substitute all the mining in the world for copper for 1.8 years. For zinc, for 3.8 years. For silver, 3.6 years, and etc., etc., etc. And everybody who has been close to a resource assessment knows that there is a wide gap of uncertainty on that part. And it is on this one as well. The point with this is that we think it could be a lot of potential out there. And I'm also fully aware that there is a difference between resources and reserves. But still, we think the potential is there. And when we do the mapping of the resources, we also do the mapping of the environment. And we also use artificial intelligence to try to map out the species that we actually see in the films and the movies and the samples that we take. And that is what you see. There's a map on your left-hand side. You see Svalbard, Greenland is to your far left, Norway is a little bit to the southeast, to put it that way, lower right-hand corner. But that is an area along that Mid-Atlantic Ridge in red, where we have done a lot of mapping and sampling. And what you see on the right-hand side is how we try to use artificial intelligence to map those species that we see in these movies and recordings. So this is also something that we do when we do the resource mapping. Now I'm just going to briefly say a few words about the regulations in Norway. And I'm sorry this is in Norwegian, but that doesn't matter too much because I'm going to talk to it anyways. Norway, I think so far, is the only country in the world that has a law on seabed mineral activity. And that is what you see on that screen is what we call a proposal or a proposition in Norwegian. That was put forward in 2017 and it came into effect in 2019. And based on that law, we made a program for an impact assessment for seabed mineral activity, and we made an impact assessment, and we made a resource estimation. Those graphs that you couldn't read a little bit earlier on came from that report that you see on that screen. And then came a white paper that was approved by the government about a year ago. And the parliament voted for this one with a big majority to continue with the seabed mineral activity in Norway. Not seabed mining, but seabed mineral activity. It was a 20-8 decision. So that was a solid parliamentary decision, I would say. This is the area, this is the yellow areas that might come out for the first concession round in Norway. You see Svalbard up to your far right. Greenland again is on your left. And Norway is to the southeast or to the lower right-hand corner. Those yellow areas, those blocks, adds up to about 106,000 square kilometers. And that is about 38% of the opening area, which was the red one that you see on the map. And some say that this is a huge area. But that area is actually smaller than the area that Norway opened up for petroleum in 1965 for the first concession round on petroleum. And we don't think that all of those areas are going to be awarded. We think that their licenses might be a block or parts of blocks. And we also think that if there is going to be any activities, we suspect that that might impact a very small area, maybe a football pitch or something like that. That's what we envision so far. And then you have the ESA, which I talked about. I will not talk too much again about ESA, but this is some of the 31 exploration licenses that they have awarded in international waters, outside the national jurisdictions. So we have to separate between the national jurisdictions and the international one, which is ESA. And then comes this discussion about moratorium. And there are different approaches to this moratorium and the voices against seabed mining. Or as it says, is deep sea mining. As you can, I don't know if you're able to read that, but it says moratorium alliances. It says some want full ban, some want a precautionary pause, and et cetera, et cetera, et cetera. So far, I think there are 32 countries that has signed up for different varieties of ban or moratorium, if you want to put it that way. Under the ESA, under the International Seabed Authorities, there are 170 member states, not 70 member states, there are 169 member states, and then it's the EU, adding up to 170. Of those, there are 32 calling for a moratorium. But that still means that there is 138 countries that has not asked for a moratorium, which is also a number to remember when we hear the loud voices about what to do and not to do. I'm going to briefly talk about the strategic resources. You know all this, and you probably have seen it before. If you haven't seen this one before, I think this is very much worth remembering. And this is a little bit what EIA and others talked about earlier on today. We are using more and more of the so-called critical or strategic minerals. And what you see on the top part of this one is how much kilograms of different types of minerals are going into an electrical car compared to a conventional car. And what you do see is that there is, I don't know, 5-6 times as much metals going into an electric car compared to a conventional car. And a lot of that has to do with the battery, but not only that. The other thing that we should also remember is the lower part of this figure, and that is how much kilograms do you need to produce megawatts of power from offshore wind, from onshore wind, from solar, from nuclear, coal, and et cetera, et cetera. And what you do see again is that a lot of these green energy producers, they also require a lot of minerals and metals. And you see the different types of metals on the far right-hand side of that slide. This is something that you also might know. This is a figure from S&P Global. What it shows is the production of copper from left, cobalt, nickel, and lithium. And in blue, it's the production in 2022. And then it's the forecast from 2030, and it's the 2040 forecast. And the takeaway from this one, without going into too much detail, is that we probably do have a challenge. And again, that was talked about earlier on today. And I'm not the one that's going to elaborate too much on this one. Again, a figure from, this is from S&P Global, where they have put together what we can have of resources from only the polymagnetic nodules in the Clarion-Clipperton zone, which is the big blue ones that you see, compared to all the world reserves in the orange ones, for manganese, for copper, for nickel, and for cobalt. So the potential resource in these metals or minerals might be significant. And that is also what we should keep in mind. Again, you know this, you know the Critical Raw Material Act, you know that Europe has kind of outsourced mining, as it says. We need to get it from somewhere. Europe, the West, US, whatever have you. What you might not know is what Draghi report says on deep sea mining. where he actually says that the EU should also carefully explore potential of environmental, sustainable deep-sea mining. Where they open up a little bit is that this may be something that we should consider. And just a few weeks back, the Federation of German Industry came out with this paper, where they are also saying that we should help the ESA getting a good standard for seabed minerals, and maybe that also could be something for us and our industry to look into. I'm going to summarize. This is James Cameron. You probably know him. I shouldn't use him as as an argument for deep sea mining, but what he is saying, I think, is something that we should remember. And I've seen a lot of seafloor and so, and et cetera, but he also say that comparable with doing mining in the deep seas where there is a lot of mud, as he says, compared to what we do other places on land, it is worth, again, considering. And then he has this expression, I think it's a question of relativity of wrong. And the relativity of wrong is Isaac Asimov's statement that there are degrees of wrongness. And being wrong in one direction might even be better than being wrong in the other direction. And now we are getting into the philosophical discussions, and I'm not going to go there. So I'm going to end with this one. I'm going to end with the dilemma we have in Norway, and this is something that we meet every day. We are being accused as regulator that we can't do anything because we do not have enough data on the deep seas. And we do not make any decisions because we do not have the data. So it's a true chicken and egg dilemma. And while we have this true chicken and egg dilemma, we also have what we see in the middle there, this perception of what it's actually looking like and what is actually happening or not happening. And I hope that I have been able to show you a little bit of the variety of seabed minerals activities. And I'm going to stop with a disclaimer, because again, it was said before the break, this is controversial. So again, I'm talking on behalf of the Offshore Directorate and not on EGRM. And I thank you for your attention. Happy to take any questions.
Thank you. Thank you, Stig-Morten. Very educational and very complete, I would say, and opening lots of questions and lot of challenges. So I welcome comments and questions from the room. Who wants to intervene, ask a question? This is your lifetime occasion to know more about seabed minerals, so take advantage of it. Please, Matthias.
Thank you, Stig-Morten. A very exciting, very insightful discussion. I think also very well placed in this forum. So what I would like to ask you, and maybe we can have some more discussions, is how can EGRM, how can the tools that we have here, like UNFC, UNRMS, how can they help you with your avenue of getting the data, making decisions, convincing those that are not convinced yet?
Yeah, that's a good. Thanks, Matthias. That's a good question. Maybe I should start by asking: are you sure that EGRM would like to start on that path? But what I think, and I appreciate the opportunity to come here, because very often when we talk about resource management, I shouldn't say we don't see the full picture, but resource management is complicated. And sometimes we have to make difficult decisions. So to be a little bit sort of open-minded, I think that the best way forward is actually that we all are open-minded and that we are trusting the data. And I shouldn't say reality, because that is not true, but that we are actually open-minded and willing to discuss also the tricky questions that we might face going forward, be it on seabed minerals or any other types of resources. Thank you.
I see France has asked the floor, please.
Thank you. Merci beaucoup. Thank you for this nice presentation of the stakes and the difficulties and also the opportunities. And thanks for it was rather deep and thorough, and with nice illustrations. I thank you for that. I would like to stress what you showed, that there is there are presently important discussions taking place at the ISA, International Seabed Authority, in order to write a draft mining code for the future exploitation of seabed. As you said, there are both known unknowns and probably unknown unknowns, given the deep environment and given our poor knowledge. And that is why, following the precautionary principle, 32 states asked that they wished a moratorium on exploitation. And this number is increasing, of course, because the number of countries, I think it was only 2 years ago that began this request for a moratorium. So, for instance, now France believes that given our scientific knowledge of the deep seabed, we believe this knowledge is still incomplete, both concerning its richness and its constitution, and also concerning the risks of possible consequences. I say possible consequences because, as you said, there might be some obvious consequences concerning pollution or biodiversity, but there might be some overestimated consequences in some debates. That's possible. So if you have to convince, it's at the same time it could be either to begin exploitation or to protect the environment or to do both. And I acknowledge that in that case, in that frame, you have Norway a regulatory framework. I hope that we can agree, and it's not really a question, but it's more a kind of a pledge or request. I hope that we can agree on the fact that we should take together the necessary time to discuss and negotiate this future mining code in order to elaborate a framework that first respects the environment with transparent procedures, and secondly, takes into account the interest of indigenous peoples and local communities, which is also a very big issue, a crucial issue in the terms of oceans and seabed. I thank you very much for this.
Thank you for your comment. I guess that wasn't a question, but I appreciate your feedback, and I fully agree to you on your precautionary principle, and that is also something that we are carrying in Norway. But again, thank you for your comment.
Thank you. Anybody else? Please, the lady. Hold on. Yeah, can you switch on your microphone? Otherwise, we can't hear you. It's the button. Is the button in the middle?
Oh, that was,
Right. Thank you.
Oh, thank you very much for that. I'm really quite impressed to see that India has issued so many licenses so far. So as coastal states begin to expand their seabed mineral claim, do you think this could lead to another geopolitical tension around critical mineral?
Could you repeat the question? Sorry.
So as coastal states begin to expand their seabed mineral rights, do you think this could eventually lead to another geopolitical tension around critical mineral, just like on land?
Thank you for your question. Whether that could lead to political dilemmas, maybe. To be honest, I'm not sure, but I do see I see where you're coming from, and I understand the question, and I think it probably won't be correct for me to discuss that one too much. But that could be an issue. Yeah, I understand your concern. Thank you.
Although for now, as you have seen from the presentation, both Norway and India are looking at their onshore shelf, which is part of under the national authority. So this is
that's correct.
Obviously, the numbers and the estimates, will have an impact on the market, but then it depends as well time to market, which is the essence when it comes to this. Radia, you asked for the floor, please.
Thank you very much for this excellent presentation, and always we have the debate when we speak about the energy transition, how it's feasible, and you did certainly did mention that the resources are maybe more on the offshore than the onshore. If we realistically, we may achieve the renewable energy target globally. But my question, since we speak about Norway as well, how this the industry, or let's say the exploration when it comes to the exploration specifically, is learning from the gas industry or the oil and gas industries. We want to do a better business model, and we want to say definitively to address the aspects specifically on the biodiversity aspect. And Norway is an example of handling this. So how you see specifically with the private sector involvement in this respect? Thank you.
Thank you. So the question was how we can advance from the petroleum and learn from it, and also on the bio. Yeah, thanks. I think there's a lot, and also one of the, I shouldn't say drivers, but one of the reasons for us in Norway to investigate these options is, of course, that we do have a lot of petroleum industry from the deep waters as well. And also the regulative system that we have put in place is to a certain degree based on what we have learned from the last 50, 60 years from petroleum, including on the environmental side. So they go in many ways, I shouldn't say hand in hand because there are different industries, but there is a big calibration and coordination between petroleum and offshore or seabed minerals activity. Thank you.
With regards to the licenses, which comes with your mining law in the deep sea, are there any kind of criteria how you define the areas where potential how you call it, applications might take place? Criteria such as let's say potential hosting areas, potential areas of, let's say, low impact on the environment and things like that. Could you explain it a little bit more?
Yeah, thanks. Very briefly, yes, it is. There is a linkage between all of that. And also, if we are getting to a licensing round, then there will be a work program. And in that work program, where the licensees get the area for investigation, there will also be a very strict part that goes on the biological or on the environmental side. So those goes hand in hand. So yes, there is a system behind that. I don't know if that answered your question or.
So there is also, you explained that there is a certain area you have identified where the licenses might take place. And this area is chosen for which kind of purpose? So is there a kind of, let's say, likelihood of deposits or whatever?
Yeah. Correct. The last, yeah. So the main reason for us to having that yellow areas that you saw on that map is the resources. And then, of course, we have to regulate those areas that might be applied for, also in terms of other, especially environmental issues. Yeah. Thanks.
The lady in the front row.
Thank you so much. And thank you for this informative talk. You mentioned something very interesting, talking about the comparison between the mining in the land versus the mining in the sea. And you mentioned that it would be less harmful to do it in the sea rather to do it in the land. But where is then the interconnectedness between all the ecosystems and the damages that are being done already with mining inland? Wouldn't they be also done in the sea? And therefore later on get to all the living organisms, including us, of course? Or how could you, how is the industry of deep sea mining analyzing this problem to bring improvements? Thank you.
Yeah, thanks. I don't think I said that it will be less harmful in the seas compared to the land, because I think if you go to the seas or if you go to the land, there are so wide variety on the way it is done and where it is done and et cetera, et cetera. So I think it's really difficult to say in general that it's this or that way. And I don't think I'm going to speak too much about land mining as well. What I do try to put forward is that at least we should try to compare and be aware of what we are already doing on land compared to what we might do when we go to the seabed. And I'm not still claiming that it's going to be better this way or the other one. That's what I said by the summing up and showing that the relativity of wrong. But I'm saying let's investigate it. So that is my main message. I don't know if Norway is going to have a big seabed mining in 5, 10 or whatever years. But I'm saying let's investigate the potential. Thank you.
The gentleman in the second row.
Thank you very much for the presentation. It is very enlightening. And of course, it has provoked some thoughts around seabed mining. Corporate entities like BMW, Volvo, Google have pledged not to use seabed mining minerals until sustainability is assured. It means sustainability is a major concern. And if that is a major concern, how can seabed mining be made sustainable, if at all it is going to be sustainable? And then how do we balance this mineral demand with ocean conservation? Thank you.
Yeah, thank you. To be honest, I'm not sure. That's and I again, I'm not saying that this or that is going to be better or this is sustainable or that is not sustainable. What I am saying is that we do have a dilemma. And what we are saying in Norway, let's try to investigate whether it might be an option. Whether, and again, also, I think that this is something a lot of us know. What is sustainability? When is something sustainable? And for whom? So I think it is a lot of big questions, and I am fully aware of that. And I don't have the answers to your question or to many of the other ones. But again, what I am saying, let's try to investigate. And I guess that's as close as I can answer. Thank you.
Hello, thanks a lot, Stig-Morten, for a very interesting presentation. It was very insightful. I would have two questions. One is that I have also noticed this strong opposition of NGOs towards seabed activity. So I was wondering where their information is coming from, since you are pointing out that there is very little to date. And secondly, I was interesting for me was to see the number of countries that have signed the moratorium versus the ones who have not. So just if you could say a little bit more on the ones who have signed the moratorium, kind of what their motivations are, and which countries these are, and where they take the basis for this decision from. Thanks.
Yeah, thank you. Well, again, I don't think I should speak for the NGOs where they get or don't get their information from. That I think is a tricky one, or if they do get the information, if I should be that candid. But and also when it gets to the different countries, I think, again, it's really hard for me to answer on behalf of those that have signed the moratorium. I think it's better that if you try to ask the ones that have signed it. What is, I think, interesting, if you remember that, as several of the countries that have signed the moratorium, there are also national institutions in the same countries that actually do hold exploration licenses in the Clarion-Clipperton zone. So there is I don't know, there is a divergent or whatever you want to call it, but there is maybe some dissonance somewhere. And I guess that's human nature. We are not always consistent. I guess that's as close as I can get. Thank you.
The UK, please.
Thank you very much indeed for the very interesting presentation. The UK recognises the growing pressure to extract deep sea resources and is concerned about the potential impacts of mining activities on the fragile marine environment. This is why the UK supports a moratorium on the granting of exploitation licenses for deep sea mining projects by the International Seabed Authority. And this means that we will not sponsor or support the issuing of any such licenses for deep sea mining by the International Seabed Authority until there is sufficient scientific evidence about the potential impact on the deep sea ecosystem. But can I follow that up with a question to you? You mentioned that there were some structures in the deep sea bed that might take 1 million years to grow by 1 centimetre in size. Do you think that reflects in some way the speed or the lack of speed with which the ecosystem might recover from any kind of disturbance on the deep sea bed? Thank you.
Yeah, that is also, thank you. That is also a good question. I think it all depends on what kind of ecosystem you're talking about and where you are, because there are a lot of different ecosystems, and there's a lot of different areas where these different ecosystems lives. So again, I think the generalization is not easy to just live by, to put it that way. So I don't know if it's going to be easy to elaborate any more than that, but I hope it's not going to take a million years. But I don't know. Again, this is something that we need to investigate, and that's what we are trying to do. Thank you.
Gentleman there, please.
Thank you for the very exciting presentation. So one of your conclusion, can you hear me? One of your conclusion is that to make a right decision, we need a lot more data. So can you please elaborate more what kind of data we need?
Yeah, I think, thank you. And I think mainly we need we need resource data and environmental data to put it on the very high ground. And then what kind of environmental data is that? Well, there is a lot, and there is a lot of data that we also need on the currents. For instance, if you want to model how this impact or the plume, which we don't think is going to be an issue, are coming. So what we are gathering right now is a lot of samples. It is a lot of photos that you saw on that screen for AI, and trying to do the environmental mapping. So there's a lot of environmental mapping going on, in addition to the resource mapping itself, where we are taking samples and also are doing AOV or indirect measurements of what could be on that seabed. So I don't know if that answered your questions.
Understood from your presentation, we have the resource and we have the technology. So if we keep the environmental part aside a little bit, are we ready for economic exploitation now? Based on knowledge we have, with the technology we have.
Again, thank you. Again, it all depends on, you say we, who are we? Is that the community, the world community? Is that the Norwegian society, or is it India that has started? Or I'm not going to speak for anyone else than the Norwegian system, because that is sort of my system. And we are saying that we are not ready. And that is why we are doing this on a stepwise matter. And that is also why we are saying that we are not doing seabed mining. We are doing seabed mineral activity and trying to get the data that we might need to get something going. This is a stepwise approach that we have used for everything that we have done on the continental shelf that I showed you a map of. And this is the one and the same approach that we will do for seabed minerals activity. And it is, I didn't say that, but also it goes that if you do have a concession round, and if there will be some licenses awarded, if anybody wants to continue with those licenses into a potential mining activity, they will have actually to come back to the ministry and to the parliament for a full decision. Thank you.
We have one more question here. The gentleman down there.
Can you hear me? Yes. My question has to do, independently from the environmental damage that these deep sea mining activities may have, and my question has more to do on the technological side and the real possibility of extracting critical minerals from the ocean, from the deep sea ocean. I'm currently finishing my research, my PhD research on rare earths and industrial policy in Brazil. And when I was there last year for a few months, making interviews and talking to people, it was mentioned several times the possibility of Petrobras, the oil company, the national oil company, using the technology they already have to extract oil from the deep seabed to also extract minerals. My question to you is, how feasible is that technology transfer? And perhaps you may have some insights from Norway, which is a country that also has an oil industry and could eventually try to make that transition.
Yeah, thank you. And as I think I touched upon it a little bit earlier on, I think there is a lot of learnings that seabed mineral activity, or mining, if you want to call it that, can get from the offshore and especially from areas, for instance, in the Brazil, where there is a deep shelf and where they have been deep, to put it that way. There's a lot with pumps, there's a lot with environment, there's a lot with drillings, there's a lot with et cetera, et cetera. So I definitely think there is a good kind of a spillover from the one type of industry to the other ones. I don't know if that answered parts of your questions. I'll be happy to talk more when we move on. Thank you.
So thank you very much. Thank you all for your participation. Thank you, Stig-Morten, for a very educational, informational, and interesting lecture. Please join me in congratulating and saying thank you to Stig-Morten. Thank you.
Thank you. Yes.
Thank you very much. And the session, the next session EGRM starts in 10 minutes. So you have 10 minutes pause and back here in 10 minutes. Thank you.